Okay, so I was going on about like the offline first stuff earlier, but there's somewhere where this has been happening for years in Chrome apps. They've been providing like privileged APIs and sort of showing the open web what it could be in future. And to talk about that, a warm welcome to Joe Marini.
All right. Hi, everybody. All right, mic on, you guys can hear me okay? Yeah? All right, how's everyone feeling? Good? I know, it's 5 o'clock, I know. You can see I've used my extreme clout as a Google speaker to secure the highly sought after 5 p.m. slot. I appreciate you guys sticking around though. Yeah, I'm gonna be talking about Chrome apps today. A couple things. First of all, I'm gonna try to speak slowly. I am a New Yorker, that does not come easy to me, but I'll give it a shot. Second thing, please keep your arms and legs next to you seated at all times till the presentations come to a full and complete stop, and then we'll go and we'll do Pinnacle, and then we'll have some beers. Just before I get started, how many people have heard of Chrome packaged apps before today? Wow, everybody, that's fantastic. All right, how many people have gone to the Chrome web store to get content, extensions, apps, whatever? All right, just about everybody, that's awesome. How about you guys on the live stream? Yeah? I'm imagining hands going up. I'm imagining it's a good thing. Awesome, great. Okay, that's good. This is me. I'm developer relations here at Chrome, on the Chrome team for Chrome apps, extensions, Chrome web store. That's my contact info. Please feel free to reach out and say hi. I am friendly. I will respond, usually nicely. Please feel free to ask questions. I love getting questions. So before I would begin, I figured 3 slides in, it's always useful to do demos, because I think demos really resonate more than just pictures on a slide. So let me just quickly show you a couple demos. We've been at Chrome apps for a while now. This is the Economist app. You may have seen this. So you can go to the Chrome web store, get this today. It's basically an app. You notice right away there's no URL bar, there's no back button, right? Up on the Mac here, there's an actual real menu bar. I can choose a story. I can keyboard through it. Got some nice performance there. What else? Let me show you something else. Here is an internet relay chat client that we built using Chrome apps. Again, all HTML5, all JavaScript. You guys are probably wondering what this red light down here is. I was going to show this later, but I might as well show it now. So Chrome apps have the ability to work with the hardware platform. So what I'm going to do is I'm going to jump over to this little sub-network I have set up, and I'm going to come over to this demo. Philips makes these light bulbs that you can actually attach to the internet in your house and just like control them with your smartphone and stuff. So you can see that as I'm changing the dials here on my Chrome app, I'm actually changing the kind. Ooh, isn't that cool? Native apps, my friends, in HTML5 and JavaScript. But I think probably one of the best demos of all. How many people use Sublime? Sublime text users? Awesome. Yes, watch. This is really cool. So I'm going to fire up Sublime text. All right, here's my Sublime editor. I'm going to size it down a little bit if I can use my mouse. There we go. So there's Sublime right there. And I'll move it, I'll just make it a little bit smaller. All right. And I'm going to go over here, whoops, and I'm going to launch this, I'm going to launch this other app called Carrot, which is a Chrome app. It was built by a guy in his spare time. And it's available on the Chrome web store today. And I've got the 2 windows. All right, and I'm going to go ahead and add a directory. Why not? Sure, that one. That looks great. Okay, which one's the Chrome app? Which one's the native app? Right? Pretty good, huh? I mean, this is HTML5 and JavaScript. It's just fantastic stuff. All right. I mean, I'm not good enough with the mouse to do the 3-card Monty. Otherwise, I'd spin them around and ask you to pick which one was which. But I'm actually not going to do that. So, all right. Let's go back to the. All right. So, of course, the question, I mean, that all looks great, right? And it performs well. You can see that we can do cool stuff. But still, you might have this question, like, why would I build a Chrome app? Why would I build a native app when the web is so great? And the web is great. We don't disagree. We're Google. We love the web. Web apps are fantastic. There's lots of great web apps out there today, and they've been around for a long time. The problem is that there comes a time when web apps just really aren't all that great, right? There comes a time when web apps are decidedly not quite so awesome. Offline is one of them. We've all seen this, right? You're trying to use the browser, and you lose the internet connection for some reason, and you get this nice white screen. Native apps don't do this, right? Native apps don't, I mean, the internet may come and go, but they're not doing this white error screens for you. Games, right? We all play games. Well, not everybody, but I play games on the web. Web games are great. You have this full, keyboard, this accurate pointing device, right? But there are times when games are just not as great, right? I mean, wouldn't it be awesome if you could give your users the ability to use real hardware controllers and game sticks and so on to play games with? This is really hard to do on the open web. There's some APIs that you can use for accessing the game controller API, but not everybody supports it, right? And not all of them work and so on. But so there are definitely some problems among others. But these are two of the more important ones. So Chrome apps are intended to help solve this problem. They run offline by default. They're basically designed by default to run when there is no internet connection. And because all the resources are packaged locally like a regular native app. So offline is a very big pillar of how Chrome apps work. They also run across all the popular platforms. Right? Just out of the box, by default, it's HTML5 and JavaScript. You get Mac, Windows, Linux, Chrome OS, which is kind of like Linux, iOS, and Android. Just out the box, okay? HTML5 and JavaScript. And I'll get into that later. I just showed a couple of minutes ago that you have access to the native hardware platform and the native OS. So you can do things like access the USB port, Bluetooth, the network, right? So they give you these really great capabilities that the native web does not yet have, or if it does have, it's kind of spotty. They give you a rich, immersive, engaging user experience, right? I mean, who would have thought that someday you'd be able to build, something like Sublime Text as a native app out of HTML5 and JavaScript? I mean, I put the two side by side. They look really great, next to each other. One's native, one's HTML5 native, but a great experience. And finally, one of the great things about the web is that you get this distribution model where you update your code on the server, and then people just get the updated app, right? And that's all great. So the way that we address this in Chrome apps is the Chrome Web Store handles distribution. It handles updates. So you write your app, right? You put it in the store. People download it. They're using it. They're all loving life. You ship an update, right? And then we use the same update mechanism that the Google servers use and Chrome uses. So every, 4 or 5 hours, right, the runtime is pinging the server saying, hey, is there a new version? Hey, is there a new version? If there is, the user gets the updated version. Everything's great, right? So these are the kinds of issues that Chrome apps are intended to address. All right. Now, I'm assuming that many of you probably have existing web apps. And there's some differences when you're building native Chrome apps using web technologies that you need to be aware of, and I'll cover some of that. So let me just begin. First, let's talk a little bit about offline. I'm going to go through each one of these in a little bit more depth. So let's talk about, for a second, what offline really means, because offline means different things. Yes, there's I have no connection, right? The network cord was ripped out, or I'm in some place like the desert or an airplane or whatever, and I just don't have an internet connection. That's one form of offline. But there's another form of offline, which is crappy offline, right? Maybe you're in a cafe and you forgot to tip the barista, and now the Wi-Fi is mysteriously not working. Maybe you work with Jake in the UK Google office, and you go to the bathroom and there's no internet, right? Maybe you're in a super oversubscribed awesome conference and the Wi-Fi is really busy in the room, right? So these are all kinds of situations and edge cases where offline really matters. And again, think back to using Sublime, right? You're sitting typing along, right? The internet goes out. Sublime doesn't care. It's not like it's getting its UI from the internet and updating it in real time. You just keep right on working. And that's because all those resources are stored locally. They're packaged up in a package, right? You don't have to generate UI on the fly. You don't have some PHP script writing out HTML. So native apps had this really great advantage in that regard, where they just recover from this. They just recover from this natively. So in Chrome apps, all your resources are packaged up locally, and your app can be launched anytime. Now, what this means is you have to plan for having a great offline experience. Right? Not everybody thinks about this stuff. And the question, of course, comes up, well, what about Service Worker? What about App Cache? Yes, Service Worker, I agree, it solves a lot of these problems. There are things where Service Worker is great for, but think it's not just a technology problem, right? It's a user behavior problem. We've spent the last 20 years teaching users that browsers don't work when they're offline. So even if we had perfect App Cache and Service Worker tomorrow, you'd still have to overcome, right, this user inertia of, I don't open my browser because why would I? right? So yeah, there's all these issues. So to plan for a great offline experience, there's certain things you have to do. First, you're gonna have to factor your app in order to work offline. So take the HTML, separate it from the JavaScript, and so on. It's always a good idea to abstract the app a little bit so that it's talking to a data layer, right? Think about how Sublime is working, right? You're working on your code, right? It's simply working on the data, and then the data layer is handling the part of talking to the cloud or talking to local storage or whatever it is, right? So if you can make that abstraction, things get a lot easier. You have to think a little bit about what your app's offline features are going to be. And yes, some applications just don't work very well when they're offline, but that doesn't mean they're useless, right? Think about an app like Skype, right? Skype, 95% of the value of Skype is only there when I have a connection, right? But when I don't have a connection, I shouldn't be like hosed. I should at least be able to manage my contact list. I should at least be able to see my call history, right? So there's still some value there. So these are the kinds of things you have to think about. Like what kinds of features does it make sense for my app to have when it's offline? We do, since it's Chrome and since it's HTML5, you do have access to things like the navigator.online property. I agree with Jake. It's not perfect. It's better than nothing. The good news is that most users don't plug their network cables into soil, right? I mean, I've only done it twice, and once was by accident, right? So, I mean, it's not most people don't do that. They actually do plug it into the wall. They use the Wi-Fi. So it's better than nothing. And we give you lots of ways to store data. Now, there's a couple things that we don't do. We don't give you window.local storage because it's synchronous, and that blocks the UX thread. So we can't have the user sitting there twiddling their thumbs while you're moving megabytes of data back and forth, right? So we try to fix that by giving you asynchronous versions of synchronous APIs that would ordinarily be in the web. So for example, we don't support synchronous XHR, right? Who does these days? Why would you do that? So we give you asynchronous versions. And Chrome Storage Local is our asynchronous version of window.local storage. But you can use IndexedDB. You can use the HTML5 file system API, right? There's lots of different ways to store data. And the reason for this, the reason why this works is because if you look at the way Chrome apps are structured, you basically build them the way that you would normally build your web app. You have your HTML, right? You've got your JavaScript. You've got the other assets that make up your application. And then all we ask you to do is put a little infrastructure around that, right? There's a manifest file that you write that defines what the app is and does, what its name is, what its description is, what permissions it has, where the entry points are, that kind of stuff, right? Then there's a file that you get to define. I've called it main.js. You can call it whatever you want. You specify this in the manifest. And that's the file that takes care of the entry points into your app. So there's an event, for example. Hey, my app got launched. Hey, my app got restarted. A cloud message came in. An alarm went off, right? So this is where you handle those kinds of events. And that's what is all wrapped up into a zip file. So all of that gets packaged up into a zip. That goes up to the Chrome Web Store. And then you're in business. We spend an hour, scanning your zip file, making sure, you're not trying to steal people's email addresses or whatever, right? We do a whole bunch of security scans, and then you're published, right? We don't review your app. We don't do any of that, in-depth stuff. You're good to go. So to take an example, right? Here's the Chrome Storage API. So you can see that normally if I had a form and I want to save some data in the form, I would just get the value out of some text area, and then the Chrome.storage API version of this function simply takes an object with properties in it, and it's asynchronous. So there's a callback function for when it completes. If you care about it, great. If not, it goes on its merry way, and your app is good to go. Okay. So very heavy emphasis on asynchronous stuff. In addition to being offline by default, we are cross-platform by default, and I talked about this a few seconds ago. If you think back to what you used to have to do to build native apps, right? Like a long time ago, if you wanted to build a rich native experience, and I'm talking about a long time ago. I mean, I know many of you were not born like when I'm talking about this time period, but there was a time when all you did was target basically Windows, right? You built a native app for Windows. If you really cared about the 10% of people who didn't have Windows, you built a Mac version, right? And that was native apps like some time ago. Now, contrast that with today, right? Today, you still got Windows, but you got multiple versions of Windows, right? You still got the Mac, but there's multiple versions of the Mac, right? Then there's iOS and there's Android, right? Now there's got all these great native mobile platforms that are coming up. Linux is in the mix. What does Ubuntu have? 20, 25 million users, right? There's a lot of people out there use this. Then of course there's Chromebooks, right? 4 out of the top 5 selling laptops on Amazon right now are Chromebooks. Hard to believe, but it's true. So you've got all these rich platforms, right, that you'd have to deliver a native experience for, and there's costs involved here. Just on this screen alone, there's what? There's Objective-C, C#, right, Java, C++, all kinds of native APIs, right? They're different for each platform, right? And then there's all the hidden costs that developers never think about, like building installers, building updaters, right? Long time ago, I worked at Macromedia on Dreamweaver, and I was tagged as the installer guy. You don't ever want to be tagged as the installer guy. You will never get away from being the installer guy. Every question comes to you about the installer. But these are the kinds of things that Chrome apps get you away from. We handle the installation, we handle the updating, we handle the cross-platform stuff. So it's another great advantage of Chrome apps. In addition to being offline and cross-platform, we have a very heavy emphasis on being cloud-enabled by default. And that's because users increasingly expect this. They expect that their data is going to be in the cloud, they expect it's going to be synced, and we give you a bunch of features that let you leverage this stuff. So I talked a little bit earlier about the Chrome Storage Local API. There's also a sync version. You guys notice that when you're using Chrome, you have all these bookmarks, and you've got different versions of your, you got different computers, and they all sync across all your Chromes, right? We just give that to you. We give you that infrastructure. So all you got to do is call a few lines of JavaScript, and your data and preferences and properties get synced across your application. No special work you have to do. That's for smaller data sets. For larger data sets, there's a sync version of the HTML5 file system. So you can store megabytes of data, and it's backed by Drive. Now, today it's backed by Drive. It's extensible. So if somebody else wants to build a syncing architecture, they can do it. But out of the box, it's backed by Drive. There's a cloud push messaging API built into Chrome apps. This is one of the cool things about Chrome apps. Let's suppose your app isn't even running, right? The user's got their laptop open, they're doing something, but they haven't launched your app yet, right? The Chrome runtime is running, though, and it's listening. So you can actually send a cloud message through our servers to the Chrome runtime. Chrome will wake your app up, right? Tell it that it got a message, which is really cool. You can't do that on the open web today, right? There's no way for a web app to wake the browser up and be like, hey, go to this URL, right? That'd be scary, right? But Chrome apps can do that. Chrome apps can listen to cloud messages. There's an identity API. Who loves writing OAuth code? Loves it. Yeah, I don't either, right? We've got an API that handles this. So doing things like authenticating users is easy in Chrome apps. We have one API function that's specific to Google services. And because you're signed in when you're using Chrome apps, basically what happens is you call this function, you say, I want to see who the user is, you get the token back, and then off you go. There's also a function that you call for third-party services. So if you want to authenticate using, I don't know, Twitter or whatever, right, there's a way to do that. So just to give you an idea of what this looks like, for the sync file system, the first example shows how to use the synchronized file system to sync data. The first line basically says, set the conflict resolution policy. These are things you have to think about, right? Data conflicts. And you have a choice. You can say, you know what? I want the last write to win. Or you can say, you know what? I'll just handle it. Don't worry about it. But then once you have that, you just simply call request file system like you ordinarily would on any other HTML5 file system API. You get an FS object back, and then you're working with the file system, just like any other file system, only this one is synced, right? Just for you, just taken care of. For identity, the two APIs I talked about, the first one, get auth token, that's for the Google services. So if I'm signed in with my Gmail account, whatever, I just call this function, and I can specify whether I want it to be interactive or not. And then there's a callback function, right? There's that asynchronicity again. The second version, the launch web auth flow, that's the third-party version, right? And so because what happens in OAuth normally is you have this redirect URL where the third-party service calls back to. That this is an app, so there's no like web page to do this. We have this function right here. There's a callback function that takes the redirect URL. So when that gets called, all you do is get the token, and you're off and running. You're signed in, right? Pretty straightforward. All right, how am I doing on time? Good, all right. So I talked a little bit about immersive user experience. Chrome apps obviously live outside the browser. They can have richer interfaces and experiences. This, of course, means that your app is going to be responsible for things that it was not responsible for in the past. And it's important to remember that users, they just have different expectations of apps versus websites. They expect deeper platform integration. They expect better performance from a native app. Even though users want great performance from web apps, I don't want Colt to come running up here and like smack me in the head. But yeah, they expect great performance from web apps, but users basically understand I click a button, it's got to go to the server, get the content, and come back. native apps, they don't have that expectation, right? No one expects like a text editor to go off to the web and get content and come back. They want responsiveness. So they expect that. Because users just aren't in a browser frame of mind when they're using an app, right? They're just not thinking in that mindset. They're using an app and they expect it to work flawlessly and quickly. So we give you some APIs that help out with this a lot. So first, we give you a full windowing API to manage your app's windows. So you can do things like see how big the screen is, see how many screens there are. You can do things like figure out where to put initial windows. You need to remember, this is an important thing. This is an example of something that's subtle, but users expect this. In the past, the browser basically said, here's your window, and here's where you are, and here's how big it is, right? And your web app was like, oh, okay, I guess that's where my window is. Well, apps don't work like that, right? Imagine how frustrating it would be if every time you close Sublime, you open Sublime, you get it right where it is, you get the window size, you close it, it comes back up again, and it's this big, right? That would drive you nuts, wouldn't it? Well, it's going to drive Chrome app users nuts too. So you have to remember things like remembering window location, remembering size. Now, the good news is we'll do that automatically for you if you give your windows IDs. So there's not a whole lot of work involved on your end, but examples of things that people expect. You can control whether the OS title bar is shown. You don't like the title bar? Don't show it. Make your own. It's HTML. And then what we do is we give you this little WebKit app region, whatever. You specify that the drag property on whatever you want to be the dragger, and then that's it. That's your title bar, or whatever, other drag regions. So full control. We give you a context menus API. Users have this annoying habit. They right-click. They want something to happen, right? And so we give you this native API to do this. What's cool about this, though, is that the context menus API works outside the app. So you can specify that if somebody right-clicks on your app icon in the launcher, you can specify the content that goes in there. So it's pretty cool. Nice native integration. There's an alarms API. There's an API for getting the media galleries on the user's computer, right? Now, all of this is obviously behind permissions, right? But you can do things like get photos, get movies, get music, right? There's just built-in ways to do this. You get a file system just like you'd expect any other file system. So the user says, yep, you can have access to my photos, right? There you go. There's a URL handlers API, right? So you can specify that your app, as long as you own the URL, right, you can specify that your app is the handler for a specific URL scheme, right? Now, you have to own the URL. Your app can't say, oh, yes, I handle Gmail URLs, right? No, it's got to be, you've got to prove ownership of the URL or the pattern, at least, and you do that in the Google Webmaster Tools, and then your app is able to respond intent-like to users clicking on URLs in emails, for example. So we give you really great ways of making an immersive user experience. All right, let's talk a little bit about integrating with the OS. I showed this a little bit earlier. So Chrome apps have access to the native hardware platform. You get access to the USB port, Bluetooth, right, the network. You can go out and discover devices. Obviously, this has privacy and security issues. It sure would be crazy if I was able to control this light bulb from my friend's house, right, or whatever. So again, this is paramount. Once you start accessing things on the user's hardware and so on, privacy and security become really, really important. So it's important to be clear to the user about when you're using resources on their system. Now, in some cases, you don't have a choice, right? Like you turn on the camera and the little light comes on, right? You don't have any control over that. But in other cases where you're using files or storing large amounts of data, just be clear to the user about what you're doing, right? It's really important. And of course, when you're done, you got to release this stuff because it's shared by the system. Share. Got to share. All right, how am I doing on time? 5 minutes. OK, let's talk a little bit about application security and CSP. Who's heard of CSP? Everyone's heard of it. That's great. I won't go deep into it. I've included the link in the presentation so you can read more about it. Basically, there are certain content security policy defaults that apps set and that you can't override. So for example, you can't use things like eval in your Chrome apps. You can't use things like new function. All your JavaScript code has to be in separate .js files. And the reason is because if somebody puts a script tag in the head of your page and we have no idea how it got there, did you put it there, did they put it there? We don't know, right? So it's got to be in a separate file. You can't do things like inline event handlers. You got to do things the new school add event listener way. Iframes, you can use iframes, but they're sandboxed into their own origin in the page. So you can post message into and out of an iframe, but the iframe can't get into the parent page and start calling Chrome APIs. Again, that would be bad. And you've got to declare where your content comes from if it's not local. So if you think back to that Economist app, it was showing all those images. One of the things you can't do in a Chrome app is just simply say image tag, path to random image on web, right? Because you have to declare local content. Now that's a pretty common pattern. So we've actually written a library that handles this for you. It'll go out to the web, XHR stuff down locally, and then you use blob URLs or object URLs to refer to them in the app. Paul Lewis actually wrote that. It's a really great library. Of course, you might really want to do that stuff, right? But wait a second, I really want to do that stuff. I really want to use eval. I've got a templating library. We do provide ways to get around some of these limitations or security measures that we've put in. So first, we have a web view component that you can embed inside your apps. It's actually, it's the rendering engine of Chrome. It's not Chrome itself. There's no extensions that come in, right? But it's the actual rendering surface of Chrome. So what you're basically doing is embedding Chrome inside of Chrome, and it gets a little Inception-like at that point, but it actually works. It's really cool. So you can use things like, you can do things like embed web content. And again, you can do the post messaging. They can communicate with each other, which is great. You can execute script in the web view, which is great. For accessing remote resources, I talked about this. It's that XHR library that Paul wrote. For templating libraries, this is where things get a little interesting. Because if they're using eval, a new function, there's a couple of things you can do here. One, you can pre-compile your templates, right? Handlebars does this, for example. Or there's a way for getting around this stuff. You can declare a page in your application, and it doesn't have to be visible, as a sandboxed page. And then what happens is all that bad stuff is now OK again. You can do things like eval and new function, but that page is kept separate, right? It doesn't have access to the Chrome APIs. It can't do things like call the Chrome stuff in your application, and you use post message back and forth. So you could put the template library in that page, send a message, have it do all of its stuff. It sends the results back to you, and so then everything's all nice and safe and isolated. All right, mobile. Let's talk about mobile really quick. I've got a couple minutes left. So we are working to bring Chrome apps to mobile devices via the Cordova project. Who's heard of Cordova? All right, it's about everybody. OK. So Apache Cordova basically is the open source version of PhoneGap. When Adobe acquired PhoneGap, they open sourced the code. Kind of like we have Chromium to Chrome, right? They've got Cordova to PhoneGap. Basically, that's basically what it is. So we're working to bring a set of key APIs over from the Chrome API set to mobile where it makes sense. We've got about 6 or 7 that we've worked out so far. We think probably by early January, we'll have a beta-ish version for you guys to work with. And it'll be great. You guys will be able to write one code base. You'll get mobile apps and local apps. The workflow is pretty straightforward. You install the tool set. You can import an existing Chrome app or start from scratch. It's up to you. You iterate over your code, you debug, and then when you're ready to ship, it goes into the native app store, right? Because these are native apps. They don't go in the Chrome Web Store. So for iOS, it goes to the App Store, right? For Android, it goes to Play, right? So that's not Chrome Web Store is only for the desktop version. So that's a key difference. So these are the APIs that we're going to support initially. A lot of these are pretty well baked already on Android. We're working to bring some of them to iOS. Actually, this may be a little bit outdated. I think we might actually have notifications now. But this is the initial API set that we're working on. And it's a thing of beauty. Let me show you. Remember that internet relay chat client I showed you a few minutes ago? Let me just do this. I'm going to bring this up right here. I'm going to tab over. OK, so there it is. That's the IRC client. Let me bring up the other one so you guys can see. You can see it side by side. Right, there's that one. Right, there's the UI. There's the mobile version running on my Android device. Same code base, HTML5, JavaScript, right? CIRC running both my Android and my desktop. Oh my God, same code base? Yes, female audience member, same code base. Same stuff. All right. So if that's got you interested, if this is exciting, if you think that Chrome apps might be something you might want to work on, these are the URLs you need to look for. We've got our GitHub repo, the Chrome app samples. All the APIs that are in the platform have a corresponding sample. Developer.chrome.com/apps is where you go to learn about all this stuff. We document all the APIs there, and it looks like I'm about 7 seconds early, so thank you very much.